Good morning again, eights. So I want to be honest, there's a potential that I will talk too much on this topic, so I'm going to try to go quickly. And the reason I'm afraid I might talk too much is it's one of my favorite topics in all of mathematics. I actually spent a significant amount of my college career studying the connection between geometry and algebra, which is crazy because they're such different sciences. So geometry is super concrete with these diagrams that we draw. Algebra is super abstract. We start out with the numbers and then we remove the numbers completely and we have algebraic relationships, but it's super abstract. So these feel very, very different. Also, algebra is super numeric and geometry is super spatial. But when we use ideas of symmetry, we can connect these two ideas and show that in a lot of cases, they're exactly the same thing. So as a definition, I wanted to say asymmetry is not asymmetry, but a symmetry is a transformation, usually a rotation or reflection, that maps an object onto itself. So let's use that definition and look at an example. What would the symmetries of an equilateral triangle be? Well, I want to find transformations that map an object onto itself. So here's my object. I'm going to take this other congruent object. I know it's not perfect, but it's pretty close. And I'm going to look to map the blue triangle onto the red triangle using transformations. And I've noted usually they're rotations and reflections, and in this case that'll follow. So one way I can change the blue triangle, the matchup onto the red triangle again, is I can rotate. If you notice, I'm going to rotate counterclockwise. And the reason is there has to be a decision made as to which direction we rotate, and there are mathematical reasons that we make that decision. It's really because the positive x-axis is on the right. So, well, let me just do this. Positive x-axis is on the right, and the positive y-axis is on the top. So if I start at some point here, which direction should be the positive rotation direction? Well, it would go towards the positive y direction. So that's why the positive direction goes counterclockwise. Okay, we rotate, and I see the blue triangle matched up on the red triangle perfectly. They're exactly the same. I rotated in that case 120 degrees because I can see that it's 1/3 of the circle. So 120, 240, 360. And on that note, I can see if I keep rotating, I end up on the same thing again. If I rotate 240, and if I keep rotating, I'll end up on the same triangle again. It's kind of obvious when you think about if you rotate 360 degrees, you always get back to where you started. So rotation of 360. But if I'm honest about this rotation of 360, it's the exact same thing as doing nothing. So we actually give that another name. It's pretty important, the idea that we can do nothing. And that name is an identity. Good, so we have identity. I don't know why I typed doing nothing and then wrote identity. I should have typed them both. Anyway, we use different letters for it. I'm going to use the letter E in this case, but I is also common for an identity. So rotating 360 is not the way we'll call this because it's the same thing as doing nothing. So we'll just call it the identity instead. The other symmetries, those are all the rotational symmetries, but we have reflection symmetries. So if I picture reflecting in this line, you can see that points 3 and 2 will flip spots, but the triangle would map up onto itself again. So I'm going to call that reflection 1 because the mirror for reflection goes through vertex 1 in the identity the way it's mapped up now. So the same thing, I would have another reflection 2 that would, these would switch spots, but I'd map up onto the triangle, and I'd have a reflection 3 as well. So the symmetries of the triangle of an equilateral triangle are reflection 1, reflection 2, reflection 3, rotation of 120, rotation of 240, and the identity. That's all of the symmetries of an equilateral triangle, saying that an equilateral triangle has 6 symmetries, and they look like this. So identity means none of the corners switch places, they're all in normal spots. Rotation of 120 means I take 0.1 and rotate it down here. Everything rotates. 240, we rotate it, end up there. Reflection 1, mirror goes through 0.1. Through 0.2 is reflection 2. Reflection 3. All of these are symmetries, and they are all of the symmetries. There are no more for an equilateral triangle. I want you to use this idea and try to come up with what are all of the symmetries of a square. I'll be honest that there are 8, and I think you're able to come up with all of them. If not, I want you to send me either a Microsoft Teams or an Outlook, and we'll get on Zoom right away, and I'll help you find the ones that you couldn't find. If you find all 8, awesome, then continue with the video. But now I want you to pause it, find the symmetries of the square. If you can't find 8, contact me, and if you do, then I'll see you in a minute. All right, 8s, I'm assuming you found all 8 symmetries of the square and you're back. So now we know the idea of what symmetries are. We've seen triangles, or equilateral triangles have 6 symmetries, squares have 8 symmetries. The next thing I want to talk about is compositions of multiple symmetries. So we don't just have to do one symmetry, we can actually do multiple symmetries. So as an example, let's say here we did nothing and then did nothing. So if I take this triangle, a blue triangle on there, first I'm going to do nothing, and then I'm going to do nothing. So it should be pretty clear what we ended up doing there was nothing. Okay, well next I'm going to rotate 120 degrees, and then I'm going to do nothing and see what happens. Okay, so if I take this, I'll rotate 120 degrees, triangle maps up onto itself, and then I'm going to do nothing. Well then all I've done is rotate 120 degrees. So I can just duplicate and throw this in there. Same way if I rotate 240, same thing if I do a reflection 1 and then do nothing. Reflection 2 and then do nothing. Reflection 3 and then do nothing. So it makes sense if our column here is that I'm doing nothing, then the only thing I've done is whatever, or sorry, if our row is doing nothing, the only thing I've done is the column operation. So great. Same thing happens if my column is doing nothing, then I can fill these in. And after this, we'll get to the interesting ones. So all of these, if I do nothing and then perform an operation, all I've done is that one operation. That's all I'm saying. So now let's look at the rest. What if I rotate 120 and then I rotate 120? So, okay, here we go. I'm going to go ahead and rotate 120. I end up there. Rotate another 120. I end up there. And I can see where I ended up. How we see where we ended up is we look at, of all of these operations, which one did we end up at? Well, I ended up with the blue numbers. So 2 is at the top, 1 is at the right, 3 is at the left. So I look for that. 2 is at the top, 1 is at the right, 3 is at the left. I end up with rotation 240. So when I rotated 120 and then 120, I end up with a rotate 240, which is obvious when you think about it. That's the wrong one, rotate 240. It's obvious when you think about it that way, but when I note it, when I wanted to get across how do we find out where we ended up, well, we match it to one of the operations, and that tells us where we ended up here. So, or one of the symmetries. So if I rotate 240 and then 120, well, that's kind of obvious because 240 and 120 are 360. This is going to get me back to doing nothing. It's where I started, but I could look at that. Here's a rotation of 240, and if I go another 120, I end up where I started. Let's look at the interesting ones, and then I'm going to ask you guys to try to go ahead and complete the table. Let's look at, for example, reflection 2 and then rotating 120. So if I reflect in 2 and then rotate 120, it's easiest for me to go ahead and look at reflection 2 here. So I've done this first. So I end up with 2 and then 3, 1. So it's just 1 and 3 have switched. That's it. Let me see if I can do this actually. So 3 and 1 switch. Oh, dang it. 2, 3, and 1 switch. So that's reflection 2. We started there. And then the other thing I wanted to do, reflection 2, and then rotate 120. So if I take this blue and I rotate 120, I'm going this way and I'm leaving my numbers behind. So I'll do them now. This went here, this here, and this here. Good. So I end up with 1 in the top, 2 on the right, 3 on the left. So where do we end up? 1 on the top, 2 on the right, 3 on the left. That's the same as reflection 1. So here we did reflection 2 and then rotated 120. And what we saw is we ended up, that's the same as just doing reflection 1. So interesting. I want you guys to go for filling in the rest of this table. Try it out. I am not worried if you make mistakes, but yeah, I just want you to try messing around with these triangles, see where the numbers end up. You're welcome to look at this key down here to see where you ended up and fill in the rest. When you're done, then push play again. Welcome back, 8s. I assume you filled in the rest of this table. And now go ahead and check your work. You should have things like this. I think the way I set up the previous table, you actually have flipped. No, actually this table is wrong. This column and this column should be flipped. So switch those. And then it'll be right. I guess I should do that. It's these should be to the right. I wish I had a faster way to do this, and I'm sorry. And yeah. This is right. And then this stuff. So you should have a table a lot like this. Great. And again, if you make mistakes, I'm not worried. I wanted you to get experience with it. The next step, I want you to create a similar table to find the symmetries of a square. This triangle, or this table is 6 by 6, but the square has 8 symmetries. So your table is going to be 8 by 8. Try to fill in that table and see how it goes. If you don't feel confident, then just send me a message and let's chat before you do it. But next I want you to fill in that table, find the symmetries of the square, pause the video now, and either contact me or continue. I'm assuming that you're back, you've found the symmetries of the square and filled in this entire table. The last thing I wanted you to look at is you have all this experience with these symmetries, with compositions of symmetries, and now we can look at some interesting similarities between geometry and algebra. Over here on the left, I have the triangle symmetries. On the right, I have a multiplication table. In your notes, you have the symmetries of the square. I want you to look at these and as a last step, write in any similarities or differences that you see. Personally, I see some similarities, like considerable similarities here. One, I guess I'll use different colors. One similarity I see is when I look at like this row and this column, they do things that are interestingly similar to this row and this column. If I look for a difference, for example, well, now maybe I'll leave you there. There are differences as well. You can find them. Best of luck, and I will talk to you soon, 8s.